In this video, I will be explaining you the converse part of the theorem maps into products. Okay, so here in another video I have explained you the first part of this theorem. So here you can see the converse part. Okay. Conversely, you are going to assume the second part here. Now, in the previous part, what you have done, you have assumed the first part and you proved this part. Here, what you are doing is, now, you are assuming this and you will prove f is continuous. Okay. So, this is very easy actually. You are going to prove f is continuous. We are having a mapping. A mapping is given in the question statement also. So, I will write that mapping here and I will explain you again. So here we know that if you want to say this f is continuous, what we will say, you will take an open set in general, okay? Generally what we will do, so to say this function is continuous, I will tell you, okay? So first you will take an open set from this set, okay? You will take an open set. Here this set is x cross y format. So the open set will be like this, u cross v. Okay, you are taking an open set from this x cross y. If you say the inverse of this open set is open in this A, then the f is continuous result will be proved. Okay. Okay, what I have said? Yeah, first you are taking an open set from this x cross y. This open set is in this format. Why this open set is in this format? Because the set is in product format, x cross y. So the open set that you are taking from this also will be like this. Okay, so what if you say that the inverse, that is f inverse of u cross v, u cross v is open in this A, then f is continuous. Okay, using that ideology you are going to prove this part. Okay, so here you are going to say prove f is continuous. Okay, so you are taking an open set from this x cross y. That's the first line, and then that is to prove f inverse of u cross v is open in A. To say that you have to prove this condition. If you proved this, then f inverse of u cross v be open in A will be proved. If this is proved, then you can say this f is continuous. Okay. So you are going to say f inverse of u cross v is equal to f1 inverse of u intersection f2 inverse of v. So to prove this, what you are doing is you are taking an element from f inverse of u cross v, and at the end you will say that that the element you are taken from f inverse of u cross v is also in here also. The same element, the element A is in here and also in here. Okay, so if you say that, then what will be, you come to know this set and this set is equal. So that is what the condition that you are proving here. Okay, let A belongs to f inverse of u cross b. So you are bringing this f to this side so that you get f of A belongs to u cross b. If and only if f of A is equal to belongs to u cross v, f of A can be written like this. How? In our statement we have f of A is equal to this value. Okay, so you are substituting that value here, f1 of A comma f2 of A belongs to u cross v. Now if and only if f1 of A belongs to u, you are splitting it, f1 of A belongs to u and f2 of A belongs to v, and okay, f1 of A belongs to u and f2 of A belongs to b. Therefore from this you can write, you are bringing this f1 to this side, so you get A belongs to f1 inverse of u and A belongs to f2 inverse of b. Now from this here, A belongs to here and A belongs to here. A is in both here and here, so you put intersection. Right, so that is why A belongs to f1 inverse of u intersection f2 inverse of v. This proves the claim. So you proved this equal to this. since f1, from the assumption f1 and f2 are continuous, you can say f1 inverse of, right, f1 and f2 are continuous means what? You have a mapping for f1. Actually, this is very easy. When I learned it for the first time, I had no idea, but after putting some efforts to know more about it, now I feel very easy, and I feel like here is nothing to feel difficult. Okay, since from the assumption you are having f1 and f2 are continuous, you know the definition for continuous, right? The inverse image, you should take an open set. The open set from x is u and the open set is y is v. So f inverse of u will be what? Open in A. That is what you come to know from this sentence. F1 is continuous means that is what you will come to know from the definition. What do you come to know? F1 inverse of u is open in A. And if F2 is continuous, then what you will come to know? The open set from Y is V. So you can say F2 inverse of V. This F2 inverse of this V is an open set in A. That is what you will come to know from F1 and F2 are continuous. Okay. So that is what they are written. F1 inverse of U and F2 inverse of, here I have mistakenly wrote U. That is not U, V. Okay. F1 inverse of U and F2 inverse of U are open in A. So from this you can write, if this is open in A, then even if you take the intersection value, that will also open in A, right? That is, if these are open in A, this and this is equal, right? So you can say this is also open in A. So from this, at the end, you can say F is continuous. This is very easy actually. Okay, I gave you some of the hints from this. I hope you feel easy to understand what is there in the proof.